In this video, we're going to talk about the three subatomic particles that are found or help to make up the periodic table. Let's go ahead and get started. There are three main particles that make up an atom on the periodic table. They are the protons, the neutrons, and the electrons. They each have a different charge, a different location, and a different symbol and mass located on the periodic table. Each of these elements helps to give them a unique feature that plays a special role in combining or bonding with other elements. Protons have a very positive charge and is often abbreviated with the plus sign. Neutrons are neutral. Neutrons are neutral, and the easiest way to remember this is they both start with N-E-U-T, N-E-U-T. Protons and positive both start with P. Electrons have a very negative charge. Now, many people think neutrons are negative because they both start with N. Do not fall into that trap. Neutrons are neutral because of the beginning of the letter. Now, protons are found in the nucleus. Neutrons are also found in the nucleus. Electrons are found in the orbitals or energy levels that surround them. The symbol for protons is a P with a plus sign. The symbol for neutrons is an N with a nod or a 0 for neutral. And electrons, the symbol is E with a negative sign. The mass of a proton is 1 AMU or atomic mass unit. Your mass of a neutron is 1 AMU or 1 atomic mass unit. And your mass of an electron is so small that it does not count into anything. It would kind of be like if a feather fell onto one of your books, you would not know that your book weighed any heavier. Or if you lost a single strand or a few strands of hair, you would not notice a loss to the weight of your body. Now, how do we figure out the protons, the neutrons, and the electrons using your periodic table? Now is a great time to either get your periodic table out or Google a periodic table image. Now, every periodic table is set up slightly differently, but they are all generally the same. For this periodic table, there is a key up here. The number on the top tells you that it's your atomic weight. Then it gives you your symbol, which is the letter, either single or there's two letters together. The bottom number is your atomic number. And then the name at the bottom is the name of the element. Now, some periodic tables, the atomic number is at the top, and some periodic tables, the atomic weight is at the bottom. So it's important to look and realize what the numbers are and how the periodic table is organized before you start. The easiest way to do that is hydrogen will always have an atomic number of 1. Helium will always have an atomic number of 2, so it always goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. So just keep that in mind when you're trying to decipher the atomic number versus the atomic weight. Okay? So on this periodic table, that top number is your atomic mass or your atomic weight, so how much does that element weigh? Then you have the symbol, which is pretty much self-explanatory. It's like your initials for your name. Then you have your atomic number and the element name. So how do we figure out the protons, the neutrons, and electrons from just these two numbers? There are many ways you can do this. The atomic number is going to tell you the number of protons for that element. The atomic number can never, ever be different than the number of protons. So for example, each of you has a student ID number. If you changed your student ID number, you would no longer be that student. It would be a different student. If you change your protons, it's the same way. You're no longer talking about that element. You have changed your element. For example, if we look at nitrogen, nitrogen has an atomic number of 7. If we change the atomic number, the number of protons changes, and we are no longer talking about nitrogen. Let's try another one. Take a minute and find magnesium on your periodic table. The symbol for magnesium is Mg, and it is number 12. So since magnesium's number is 12, we know that it has 12 protons. If we were to add 1, we are now at 13, and it now becomes aluminum. And if we take 1 away, it becomes sodium. The element symbol is used to represent an element. When we start writing balanced equations and longer things, we don't always want to write out the element name, so we use the symbol. The element name is pretty self-explanatory. And then the atomic mass is the number of protons plus the number of neutrons in the nucleus. Okay? And we will do some practice with this. Just a side note, the periodic table does publish the average atomic mass of those numbers. Okay? All right. So, how do you get the neutrons? Another way to remember this is the acronym MAN, M-A-N. The mass number minus the atomic number is your neutrons, okay? Or you can say protons plus neutrons equal your atomic number because your neutrons are here. Atomic number is the same as your protons, so neutrons plus protons is your mass number. That's another way to think about it. So let's do some practice. Take a minute and find carbon on your periodic table. Carbon's symbol is C. So once you find carbon, we can see that the atomic number is 6. If the atomic number is 6, then we know the protons must also be 6. Now, since you have 6 positives, your positives and your negatives, since these are all neutral, must be equal. So since we have 6 positives, we must have 6 negative electrons, so that number is also 6. In the practice that we do today, all of these elements will be neutral. None of them will have a charge of plus or minus, so all the protons and electrons must be equal. Now we have to find our neutrons. Remember, you can do your mass number, which is 12, minus your atomic number, which is 6. So 12 minus 6 is 6. Okay, let's try the next one. The atomic number this time is 1. So which element are we talking about? The first element on the periodic table is hydrogen. Now, since the atomic number is 1, you know that your protons must also be 1. Since your protons are positive, if you have 1 positive, you know you have 1 negative electron. Now we have to find the number of neutrons. Our mass number is 1, so mass number minus atomic number, so 1 minus 1 is 0. Now some people will argue that it's 0 or 1, but most of the time it is 0. All right, let's go to the next one. Here we have the number of protons is 7. Now since we know our protons are 7, what must our atomic number be? If you said 7, you are correct. Remember, protons and atomic number are always the same. So here we have our atomic number of 7. So which element is number 7 on the periodic table? If you said nitrogen, you are correct. Now since we have 7 protons, we can do our electrons. Our electrons are 7 as well. Now the mass number. The mass number also comes from the periodic table. On the periodic table that we are using, if you're using the Massachusetts Comprehensive Assessment System 1, it is that top number. Notice it has 14.01, so we are just going to simply round to 14. If it's a 0.5 or higher, you can round up. If it's 0.1, 2, or 3, or 4, you can round down. So now that we have our mass number, we have our atomic number, we can find our neutrons. So mass number is 14, atomic number is 7, so 14 minus 7 is 7. Let's try the next one. Take a minute and find cesium on your periodic table. The symbol for cesium is Cs. Did you find it? Hopefully you did. The number of protons is 55, so that means your atomic number is also 55. So it's number 55 on the periodic table. Now, since our protons are 55, our electrons are also 55. And I do want to draw your attention to the mass number. If you look at the mass number, it does say 132.91. Since it was 132.91, we simply rounded up to 133. Now, in order to get your neutrons, you do the mass number minus the atomic number. So 133 minus 55, and you get 78. Let's try one more together. The next one we're going to do has an atomic number of 74. What is that element? This is a weird one. It is unique. The symbol is W. The element is tungsten. Our atomic number is 74, so that you know right off the bat your protons must also be 74. Your protons and the atomic number must always be the same. Remember, your atomic number is kind of like your student ID number. If you change your student ID number, you are no longer that student, you are a different student. The same thing goes here. If you change your protons, you are no longer that element. So if you change from 74 protons to 75, you are no longer tungsten, you are rhenium. Okay? Now, since we have 74 protons, we know that we have 74 electrons. Take a minute, look at the mass number. We see the mass number is 183.85. We can round that up to 184. Now, in order to get the mass, in order to get the neutrons, you can do the mass number minus the atomic number. So 184 minus 74, and you get 110. How did we do? Are you ready to try some on your own? Take a couple minutes and try these on your own. I would highly recommend you pause the video, you try them on your own, and then you click play to continue and check your answers. Hopefully now you tried these on your own and you can check your answers. Did you get them all right? If you have any questions, please ask your teacher. Try 2 more on your own. Pause the video, try these practice, and see how you do. If you completed the practice, you can continue to press play to check your answers. Hopefully you got them all right. If you have any questions, please check with your teacher. Let's do a quick review. How are the atomic number and the number of protons related? Well, like we said, the atomic number and the number of protons are always the same. Okay, so these numbers are always the same. They are always equal, or they are always the same. Okay, how are the number of protons, number of neutrons, and the mass number related? If you said mass number minus the atomic number is your number of protons, or is your number of neutrons, you are correct. So mass number minus atomic number, which is your protons, equals your neutrons, or protons plus neutrons is your mass number. This one does take practice. If you're using the periodic table, the Massachusetts Comprehensive Assessment System, it's the top number minus the bottom number, but don't get in the habit of that because every periodic table is slightly different. All right, question 3. What is one thing that determines the identity or name of the atom? If you said your number of protons, you are correct. Remember, your number of protons is like your student ID number, and that determines which element it is. If you change your protons, you change your student ID number, and you change the element. If you have any questions on protons, neutrons, and electrons, and how to find the number respectively for a neutral atom, please check with your teacher. Thank you.